Hello everybody, welcome to Tracy Learning Chemistry videos. Today we'll be discussing about practice problems related to empirical formula. So let's see what all questions we'll be covering in this video. The first question. A compound X contains 63.3 manganese and 36.7% oxygen. So here we have a compound X which consists of manganese, that is 63.3%, and oxygen, that is 36.7% by mass. When X is heated, so we are heating this X, oxygen gas is released and a new compound Y is formed. The compound Y contains manganese 72% and oxygen 28%. Now this compound Y contains different percentages of manganese and oxygen. They are manganese 72%, whereas oxygen is 28% by mass. As given in the question that the oxygen gas is released, so you can very well see that initially in compound S the percentage of oxygen was 36.7, but when it forms compound Y, it reduces to 28%. So we need to determine the empirical formula of X and Y, and we need to write the balance equation. To find the empirical formula, two important parameters needed are the percentages that is given and the atomic mass. The atomic mass of manganese is 55, where that of oxygen is 16. Now in this question, what we're going to do, first of all, we will calculate the empirical formula of this compound, and then we will calculate the empirical formula of this compound. And after that, as per this equation, I will substitute the value of the empirical formula of X and Y to get the balanced equation. So let's start. The empirical formula of X. First of all, we need to find the moles of each and every element, that is manganese and oxygen, and the moles can be found out by dividing the percentages with the atomic mass. So the moles of manganese will be 63.3 divided by 55. This will come out to be 1.150. And when we divide 36.7 by 16, it will come out to be 2.293. These are the number of moles of manganese and oxygen. Now to find the molar ratio, we need to divide the moles of these two compounds by the lower mole value, which is 1.150. So to find the molar ratio of manganese, I will divide 1.150 by 1.150. This will come out to be 1. And to find the molar ratio of oxygen, I will divide 2.293 by 1.150. This will come out to be 1.99. So on rounding out, it will be approximately 2. Now these two molar ratios are in whole number, so we need not to multiply with some numeric value to get the simplest whole number ratio. So in this case, the simplest whole number ratio for the manganese is 1, whereas that of oxygen is 2. So the empirical formula of this compound will be manganese 1O2, that is MnO2. So now we have found out the empirical formula of X. Let us find the empirical formula of Y. So first of all, we'll find the moles by dividing the percentage by the atomic mass. So this will come out to be 1.309, and on dividing 28 by 16, this will come out to be 1.750. So for the molar ratio, I will divide the moles of manganese and oxygen with a lower mole value, which is 1.309. So this is 1.309 divided by 1.309. This will come out to be 1, whereas 1.750 divided by 1.309, this will come out to be 1.336. Now the molar ratio is in decimal, so we need to multiply this with some numeric value to get the simplest whole number. And in this case, we have to do the hit and trial method, like multiplying it with 2 or 3. So here, if I multiply 1.336 with 3, we get 4.008, which is approximately 4. So this comes out to be a simple whole number. So if I'm multiplying the molar ratio of oxygen with 3, I need to multiply the molar ratio of manganese with 3. So the simplest whole number ratio of manganese will be 3, whereas that of oxygen will be 4. So the empirical formula of this compound Y will be manganese 3 and oxygen 4. We have calculated the empirical formula of compound X and Y. Now it's time to write the balanced chemical equation. So the equation I wrote in terms of X and Y were X when heated gave us Y plus oxygen gas. These two are in the solid form. So the empirical formula of X that we found out was MnO2, that is solid, and when it was heated we got Y, and the empirical formula of Y that we found out was Mn3O4 plus oxygen gas. So these two are in the solid form. Now we need to balance this equation. If we go as per the balancing equation rules, then first of all we need to balance the metal given in the equation. So here the metal is manganese, and we need to first of all balance the number of atoms of manganese. In the reactant there is just 1 atom of manganese, whereas in product, that is Y, there are 3 atoms of manganese. So we will multiply this with 3 to balance the atoms of manganese. So now if we see the reactants, we have 3 atoms of manganese, and in products also we have 3 atoms of manganese. So manganese is balanced. Now if we see oxygen, this is 3 atoms into 2 atoms of oxygen again. So the oxygen will come out to be 6 atoms here. And if we see here, we have 4 atoms of oxygen in here and 2 atoms of oxygen, so this will come out to 6. So oxygen got balanced automatically. So 3MnO2 on heating give us Mn3O4 plus oxygen. This is the required balanced chemical equation. Thank you very much for watching this video. For more videos, you can visit our website transelearning.com. Have a great day.